I will show you how to apply the concept in Chapter 5 to solve real problems. As we know, normal distribution is the most widely used distribution in the world. And for any normal distribution with mean, mu, and standard deviation, sigma, we can use the z-formula to calculate the z-score. X minus mean divided by standard deviation, sigma. So for example, if we want to find out the probability that any normal distribution variable x higher than a number, and we can use the number minus mean and divide it by the standard deviation, and then we can use the z-table to find out the probability. Similarly, smaller than b or between a and b, we can use each side minus mean divided by standard deviation to find out the z-score. And then we use the z-table to find out probability. Now I will show you with examples. So example 1. Assume that the length of time between charges of a cell phone is normally distributed with a mean of 10 hours and a standard deviation of 1.5 hours. Now find out the probability that the cell phone will last between 8 and 12 hours between charges. First, we need to translate the sentence into mathematic form, between 8 and 12 hours, so the variable x is between 8 and 12 hours. Then we can use the z-formula to calculate the z-score for 8 and 12. That is 8 minus mean 10 and divided by standard deviation 1.5, and 12 minus mean 10 divided by the standard deviation 1.5. So the z-score, it will be between negative 1.33 and 1.33. And next, we will draw the curve and highlight the area. So we'll draw the distribution curve. Normal distribution is bell-shaped curve, and middle is 0. So from negative 1.33 to 1.33. So from here to here. And as we know, the probability will be this area plus this area. So we will have the two table value plus. And then we use the z-table to find out when the z-score is 1.33. This is the table value. And this is the table value for 1.33. Because the z-table, we only have 2 decimals, so when you use the calculator to calculate the z-score, please keep 2 decimals for using the z-table. And the probability is 0.8164, which means about 82% of the chance the cell phone will last between 8 and 12 hours. Let's see one more. How likely that the cell phone will last longer than 13 hours? So more than 13, the z-score will be 13 minus mean 10 and divided by the standard deviation 1.5. So the z-score is 2. And we will draw the curve and highlight the area. The middle will be 0, so 2 is here, and put a line bigger than 2. So if we highlight, it should be everything on the right. And we need to find out this table value. So the probability will equals to 0.5 minus the table value according to the z-score 2. So 2 will be 2.00. So this is the probability. So the table value is 0.4772, and you can calculate the result. And one more. how likely that the cell phone will last less than 11 hours. So smaller than 11 hours. And the z-score will be 11 minus mean 10 and divided by the standard deviation 1.5. So the z-score is 0.67. And let's draw the curve and highlight the area. So middle will be 0, 0.67, and put line here. So smaller, it should be everything on the left. So the probability will equals to 0.5 plus the table value according to 0.67. So let's find out the table value. 0.67 is here. .67. So the crossing is the table value. So the table value is 0.2486. So around 75% of the chance the cell phone will last less than 11 hours. Now, let's see another example for using the z-table in reverse. Suppose the score X on a college entrance examination are normally distributed with a mean of 550 and a standard deviation of 100. And a certain university will consider for admission only those applicants whose score exceed the 90th percentile of the distribution and finds the minimum score an applicant must achieve in order to receive consideration for admission of the university. So, exceed the 90th percentile, that means you need to find out a score. If smaller than that number, we write as x0. It will be 90 percentile, 90%. Or we can also write like this way. Higher than that number, it will be 10%. Higher that number, write as x0, we need to figure out. It will be the 10%. And we will use the z-score formula again. So the z-score, it will be the x unknown number minus mean. Mean is 550 divided by standard deviation 100. So it equals to 90%. Or the probability z-score, so higher than minus mean. Mean is 550. Divided by 100, so this will be 10%. Now, let's draw the curve. The middle is 0, so we need to find out the 90th percent. That means we need to find out this number. So lower than this number, it will be 90%. Or higher than that number, or higher than this number, it will be 10%. So either way works. And remember, the table is only about this area. So we need to always find out what's the probability of this area. So this area actually should be 40%. 0.4. And we need to look at the z-table to find out where is 0.4, which row and which column. Okay, so look at the inside of the table. 0.4, the closest number should be this one, 0.3997. So this one is the closest one. So which row? 1.2. And which column? 8. Which means this z-score, it should be 1.28. That is the x0, the unknown number, minus 550 divided by 100. So this number is 1.2. This number is equals to 1.28. So you can solve the x0 equals to 1.28 times 100 and plus 550. So equals to 678. So which means any student achieve this score, minimum 678, you will be considered by the university. So that's all for this video.